So 5H applications is all worded problems to do with everything we've learnt so far in Chapter 5. So if we have a look at question 1, it says, prior to a mice plague which lasts 6 months, the population of mice in a country region is estimated to be 10,000. So we're starting at 10,000. That's an important number. The mice population doubles every month. What does that mean? By 2 per month. Okay. So month 0, 10,000. Month 1, 20. Month 2, 3. All right, let's stop there for now. So is by 2 per month going to give me the equation that fits our data? All right, it's not, is it? Because if I do month by 2, okay, I can do 10,000 by 2 and I'll get 20,000, but I can't do 10,000 by and get there. So it has to be something else. All right, so when a population is doubling every month, you end up with power. So if you think about it, if you double this every month, right, then you're just multiplying by 2 again, aren't you? But you're doing it over the top. So if you're doing 3 months, it's 2 to the 3, which is times by 8. Would you agree? All right. So if we do that, 2 to the 4 is, Brandon? 2 to the 4? Huh? 16, isn't it? 2 to the 4 is 16. So if we times this by 16, 160,000. So we're double our 80,000. No, I know where you were headed. All right. So that's working, isn't it? But we have to multiply that by 10,000. So that's our rule. That's part A. Okay, express P as a function of T. So P equals 10,000 times 2 to the T. All right, where T is the time in months and P is the population of mice. So if something is doubling, it's 2 to the power of that. Okay, if something is...
substitute 0, 1, 2, 3 to 10?
Yes, so this is T, this is P on our initial table. Okay, so if something is halving every month, what do you think we should do? Put a half to the T, yeah. All right, good job. Okay, so part B is find the population after 3 months. Check. Find the population after 6 months. So we sub that in. P of 6 equals 10,000, 2 to the 6. Brandon, what's 2 to the 6?
Take that to total.
Don't know. What's 2 to the 4 again?
Big number. 16.
What's 2 to the 5 then? This is how you do it. This is what you need to practice,
64.
right? So it is 64. So it's 10,000 times 64, which is 64 with 1, 2, 3, 4 zeros.
640,000.
All right, 640,000. Yeah? Now, the next thing, and this is where you start going a little bit backwards. So that's part B. Part C is what T will make it equal 100,000. Right? So we know our population is 100,000. I can never work out how many it is. Equals 10,000 times 2 to the T, and we're trying to find T. So if we're going to undo this, we undo this at the start. So we're dividing by 10,000. 1, 2, 3, 4. How do we work that out? That's not our normal way of doing it, right? Normally this number, we can say, well, that's 2 to the power 4, therefore 4 and T are the same, so T is 4. But we can't do that here because 10 is not 2 to the power of something nice like we should know. So how do we undo it? Square root it to the power of T. Can't times it by the power of T. Right? If we go back to the last video we just recorded, a to the x is log ax. Right? They're inverses of each other. So how do we undo an a to the x?
You go
We
log
log
A
it.
x.
Okay, so if we're going to do that, we then, so that's a, that's x,
So it's log 2t. 10 equals
log 2t equals 10. Okay, how do we undo that? Now, is that the right way around, or is it log 2? No, log 2 10 equals t. Wrong way around. Log 2 10 equals t. So if you on your calculator do log 2 10, you'll find out t. Alright, so if you do log, put a 2 and do 10, you should end up with 3.32. Alright, that's how you do it. So to undo your power, you swap it to a log. Okay, so to inverse a power, you log it. This comes down here, that goes down there, and that comes in there. Alright, so that's all your applications. Notice we started with exponentials, we ended with logs because they are tied together. Right? That's why this chapter is laid out the way it is, and that's why this application stuff is so important, because you will come across problems that require this sort of information to be interpreted and then solved at the end here in your SACs and in your exams. Okay?